Hey guys, this is Kevin. Thank you for joining today's video. We're going to be discussing Leetcode problem 20, validate parentheses. So I love this problem because it was one of the first problems I solved where I was able to use a stack. And stack is basically a recursive data structure, or basically a way to contain your data. And the reason it's important is because you can use it in things like depth first search. You can compare values in certain order. And again, it was one of the first questions where I saw the power of being able to use this type of data structure. So this will be important for you when you're in your own programming interviews to remain cool, calm, collected, and be able to answer these like it's nothing. And basically what we're doing with things like using additional data structures such as dictionaries and stacks is trading in additional space in order to improve our time complexity. So let's get into it and solve this problem. All right, guys, let's jump into valid parentheses. So the overall problem statement is basically giving a string. You're going to have open parentheses, closing curly braces, opening curling braces, brackets, and they are opening and closing. So basically, it's going to be valid if the open brackets are closed at the same type. So basically, like if you have an opening brace or parentheses, it has to have the corresponding type of bracket, brace, or parentheses. So they must be closed in proper order. So for example, you can't have something like this where you have an opening parentheses and a closing bracket. It has to be in order. So you see right here, this closes with the closing parentheses right here, opening bracket, closing bracket. So it has to be a certain order. So you can see right here, it opens up with a brace, and then you have another opening one, but that is closed out immediately. So this is a proper order. So this problem in general is just all about ordering. And when I first was able to solve this, you basically get intuition for the different data structures you could use. So for this, I was thinking a stack could be useful because of the ordering. So since we know that closing brace bracket parentheses has to have an opening one to the left, a stack is useful because it can be used in last in, first out order. So what is a stack? A stack is a recursive data structure that basically contains information. And this information compared to a queue, often bunched in with a stack, is that a stack is last in, first out. So think about it like a bunch of plates. If you were to stack a plate, you put one down, that's the earliest plate, then you put another one, so that's like the last plate in, and then if you were to take off the top plate, that's the first one out. The queue's opposite, it's first one in, first one out. So think about like a line. And this is useful data structure for basically if you know data is coming in a certain order, or if you have to use depth first search. So in addition, we're going to be using a hash map or dictionary because we know when we have these closing braces, brackets, and parentheses, we have to have a corresponding opening bracket. So the reason we want to use dictionary because it's easy lookup. It's near constant time. The only time it's going to be worst case scenario is if in this particular problem you just have a bunch of opening parentheses. So you'd create an additional data structure that's basically the same length of the string. The major disadvantage of using a dictionary is that it's going to be unordered compared to an array, and but it's easy to find your particular key when you're indexing it. So for our problem, using stacks and indexes, our desired time space complexity is going to be O of n, or linear time, because we have to go through every element when we go through the stack and check whether or not we have valid parentheses, opening, closing brackets, and curly braces. And again, like you mentioned in the previous slide, we have basically a worst case scenario where you just have all opening parentheses, curly brackets, or braces. So that can create a stack the same length of the original string. So for the next couple slides, I wanted to include basically what stack is. It's almost like a list in Python and the dictionary we're going to create. So for the dictionary we're going to create, we basically want to create a dictionary where we want to look up the closing parentheses and what the corresponding opening value is. So let's say we have this, then we want an opening curly brace. And then we have a closing bracket, and we want an opening bracket. Because we're going to be using it later on in the program when we're indexing and trying to access this information. So now we're going to finally have the closing parentheses and opening parentheses. So logically what we're going to do with the stack is, as we go through our input string, just imagine this is our input string, this is going to be invalid. So I want to show you how it's going to be basically determined by using our stack and dictionary in combination. So as we're iterating through the string, so let's say for char in string or s. So what we're trying to do with the stack, and let me initialize this right here too, is basically for every character, append it if it is not in this closing parenthetical dictionary. So right here, this is opening. So basically I'm going to move this here. So that's our one of our string characters. Okay, so that's opening. So we're going to append that, and then we're going to append the next one. This is opening too. Everything is good. And then we're going to open again, and we're just going to iterate through this. So finally we come to a closing curly bracket. And since we have our dictionary here, we can see what the corresponding value is. So for a key of closing curly bracket, we need an opening curly bracket. Okay, so we're going to do basically a conditional saying that the last item, or the popped item of a stack, has to equal the value from the key in the parenthetical dictionary. So this is not equal, so that's why it's invalid. So as we're going through this, we know it's invalid. So let's code this out. So for character and string, we're going to iterate through that. If character is not in our dictionary, if it is in our dictionary, then we're going to see if the last item equals, let's see, stack.pop. If there's anything in the stack, else, let's just do some random character like pound symbol. So if parent dict is, and for this, so basically for this index character, so like we did in this example, so in this dictionary, this character, which has a corresponding value of opening bracket, if that equals the last item, which we just popped, so the stack.pop function is going to basically assign this to the last item variable. It's going to compare these two. So if these don't equal, then we're going to return false. And then if the character is not in our closing parenthetical dictionary, then we're just going to append it to the stack. So stack.append character. And then finally, if our whole string is valid, at the end the stack's going to be empty because it has a corresponding, each opening brace, curly bracket, or parentheses is going to have a corresponding closing one. So it's basically going to pop that out of the stack. So if everything's equal, then it should be empty. If there are no corresponding or closing brackets, then there's going to be some items left in the stack. So we're going to return stack. I'm going to submit this, and I'm kind of going to just take you through some more examples. So this one's valid. Let's see why. So we basically put the string opening bracket. Okay, now this next one. Remember right here, if characters in parenthetical dictionary, okay, it's here. The corresponding thing should be opening bracket. So what's the last item? We pop the last item, and then we compare it. so they're equal. So then you basically just go to the next character. So imagine that these do not exist, or they basically just get popped off. All right, then we're gonna do add this one. It's opening, it's closing. So is closing in parenthetical dictionary? It is. Okay, so these are also going to be removed. And then finally, on the last item, is this in the parenthetical dictionary? Okay, it is. So this last item, which was popped, is equal to this based on the dictionary. So this is going to be removed as well. So at the end, we're going to see if the stack is empty, and it is. So it is true. We have valid parentheses here. Same thing with this. So we go through the string, opening, opening, because it's opening and it's not in the parenthetical closing dictionary. We don't have to worry about that. It's just appending to the stack. Now finally, we get a bunch of characters that are in the parenthetical dictionary. What's its corresponding value? So its corresponding value is opening parentheses. Okay, so let's pop the stack. Last one in, first one out. Here, they're equal based on this dictionary to the left. All right, let's go to the next item. Oh, this is also in the dictionary. Okay, let me pop the last item. First one out. Okay, based on the corresponding values in the dictionary, these are equal. So, and then finally, you do the same thing, pop last item. Remember, for this item that's being compared to the popped stack element, the dictionary is basically returning a value of this. So these are equal. So that's why these get basically removed from the stack. And basically, this is valid because it's empty at the end. Same thing, same process. Opening brace, you're just adding it to the stack. You check whether or not the next character is in the closing parenthetical dictionary. It is. So what's its corresponding character or its value for the key is this. So you pop in the last element, first one out, they're equal, and they get removed. So as you can see with the rest of the elements, it's basically the same thing. You're going to be adding opening brackets and braces to the stack. And then when you have a closing brace or bracket or parentheses, if it's in our dictionary, you're going to basically get returned the value for the opening brace. You compare that returned dictionary value to the last item that was popped off the stack, and then that's all removed. At the end, you should have empty stacked. That means that the stack is, the string is valid parentheses. If not, then false. So stacks are really good for kind of these ordering and recursive solutions, and you'll see that a lot with more depth first search problems, at how stacks and in breadth first search queues are very useful. So thank you guys for watching the video. I really appreciate it. If you found this video helpful, please like and subscribe. It really helps the channel, and I'll see you guys in the next video. Thank you.